The chain rule is our weapon for deriving composite functions, okay, for finding the derivative of composite. So composite functions means when one function is inside of another function. Okay, that's what composite functions mean. So here are some examples. So let's see some examples. So the ones on the left, we don't need to use the chain rule for. The ones on the left, we could use the first one, we would just use the power rule, right? Move the 2 to the front, subtract a power, the derivative of -1 is 0. This guy is what we did yesterday, right? So the derivative of sine of x is just cosine of x. Same thing here, right? We would use, as the first one, we would just use the power rule. So the derivative of that would just be 3. We would find the derivative of this guy, which is 1, minus the derivative of tangent, which is secant squared. Right? We don't need the power. These guys look very similar to the ones we just did, except this part is inside of another function. There's something inside of this. They're inside of another function. Okay, so we still have x squared minus 1, but it's inside of a root, right? We're going to need to use the chain rule for that. You have a sine, but the angle is not just x, it's 5x. So 5x is inside of sine. Okay? You have x squared minus 1, but it's not just x squared minus 1. It's inside of a bigger part, right? To the 7th power. And same thing here, x squared instead of x. Okay? So when we have a function inside of another function, that's when we need to use the chain rule. Okay? So it's like layers. So the chain rule is like layers. So a lot of times, when I had it explained to me, the teacher I had back when I first learned the chain rule used the M&Ms. It's like an M&M, like a peanut M&M. Has layers to it, right? The first outside layer is the one you see, right? The one you see is the outside layer. That's the red shell. And then inside of that, there's another thing in there. It's the chocolate. And then inside of that is another, which is the peanut, right? There's 3 layers to it. That's the same thing with the chain rule, right? There are layers to them. The first one here, the root, 2 layers. It's got 2 layers. One is this inside stuff, and then the other is the root of the entire thing. Same thing here. Here's the first layer, here's the inside, 5x, and then the entire thing. Here's the inside, here's the entire thing. Okay, so our goal is first of all to find what is the inside, because we always start with the inside. Okay, so this is the entire function here. First thing we do is find the derivative of the outside, rewrite the inside. Multiply. Now we find the derivative of the inside. So we go step by step. You start with the outside, the shell, find the derivative of that. Everything on the inside stays the same. They call it a chain rule because every layer is chained together with the derivatives. So it depends on how many layers you have. It'll be like if we had another layer, we would chain it on here with a multiplication. Okay? Okay, so let's look at the first example. So we're not even finding derivative on number 1. We're not even finding derivative. What we're finding is the inside and the outside layer. Okay, so let's look at 1a. Cosine of 5x squared. What would be the inside layer? So yes, anytime you want to find the inside layer, go to inside the parentheses or go inside the root. That's usually where they're at. This guy is inside the parentheses. That's the inside. So the inside is 5x squared. What is the outside? So the outside is always everything. So it wouldn't just be cosine, it would be cosine of 5x squared. Okay, so the inside is by itself. The outside, so when I talk about the outside, I mean the whole thing. Okay. Letter B. Inside. When you're looking for an inside, always start inside the parentheses or inside the root. This one has a root. So the inside part is going to be 3x plus 1. The outside is always the whole thing. So the root of 3x squared, 3x plus 1, which is the same thing as 3x plus 1 to the 1/2 power. Okay. C. F of x. Letter C. This one's a little bit harder because of the way it's written. So like I told you guys, this is how they write squared in trig. I don't really like how they do that. I prefer to write it like this. Sine of x squared. Those both say the same thing. One of them is how they write it in trig. One of them is how we write it in algebra, calculus, wherever we're in. Okay? So now that I rewrote it like that, what is the inside function going to be? Inside the parentheses, sine x. So the inside is sine of x. The outside is always the whole thing. The outside layer, I should say. Okay. Letter D. We've been using the quotient rule for letter D, and you can use the quotient rule. If you were to use the quotient rule on letter D, you would get the derivative. Today, we're going to use the chain rule. I'm going to show you how the chain rule can use this problem too. Which one do you have to use? It doesn't matter. I don't care if on the test you use, if you have this question on the test and you use the chain rule, great. If you have this question on the test and you use the quotient rule, great. Doesn't matter to me because you're doing the same thing. So if it's written like that, we're going to use the quotient rule. But I can also write this as that without a fraction. So if I write it like that, it becomes a chain rule problem where the inside is 5x plus 1. The outside is the entire thing. Okay. So now what we're going to do is we're going to do those 4 problems, except we're actually going to find the derivative. So when we do that, we're going to start with the outside and then do the inside. Okay. All right, so let's flip it over. So we already did this. We already did the first part, right? We said 5x squared is the inside. Cosine of 5x squared is the outside. So what the chain rule says is find the derivative of the outside first. The outside's the entire thing. So that's cosine. So what's the derivative of cosine? Negative sine, right? So first thing we're going to do is write negative sine parentheses. That's the derivative of cosine. Rewrite the inside. We're not touching the inside yet. Rewrite it. 5x squared. Find the derivative of the outside, leave the inside untouched. Now we need a chain. Multiplication. Now we're going to find the derivative of the inside. What is the derivative of the inside? 10x. Chain rule's done. Now I would move the 10x to the front because this is multiplication. I would say negative 10x times sine of 5x squared. But that's not calculus. That's just moving things around, right? That's what I would do. But that's it. You're done. Okay. All right. Let's do letter B now. Anytime we're finding derivatives, what did we say to do with the root? Change it to an exponent. So the first thing I'm going to do is I'm going to change this to an exponent. So the entire thing is under the root. So the entire thing gets a 1/2 power. Find the derivative of the outside. So we said the outside was all of this. Don't even worry about the inside. Don't even worry about the inside right now. What I'm worried about is the outside. So the outside is something to the 1/2 power. Something to the 1/2 power. So if you had something to the 1/2 power, how would you find the derivative? Move that guy to the front. Subtract a power, right? Subtract a whole. That's what we're going to do. One half moves to the front. Going to subtract a whole. That makes negative 1/2. Rewrite the inside because I haven't touched the inside. The inside stays the same. Now we can go and chain. Now the last thing we do is find the derivative of the inside, the derivative of the green. What is the derivative of the green? Regular old 3, right? That's the derivative. Now I wouldn't leave it like that because I have things I can multiply. I can multiply the 3 and the 1/2 in front. The negative 1/2 I can move to the bottom. So I'm going to, but that's not calculus. That's just kind of cleaning it up a little bit. Okay. So what I would do is I would multiply the 3 and the 1/2 in front to make 3 and 1/2. Or 3/2. Okay. The root is right here. And it's got a negative power. So I got to move that to the bottom. And I'm going to give it back its root. Done. That part I just did right there is the hardest part. That's where students struggle the most. That wasn't calculus. You guys did that in Math 3, right? You guys did that stuff in multiplying, negative exponents. That's the hardest part. I find students can do the chain rule really well because it's not that bad. But the part they struggle with is that last thing I just did. Go from here to here. From this step to this step. That's where they struggle with. Like I said, that's not calculus. That's just stuff we've done before. Okay. All right, let's look at letter C. For letter C, we said we didn't like it written like that, so I'm not going to write it like that. I'm going to rewrite it like the way I had it before. Sine of x squared. Okay, so I'm going to start with the outside. The outside was something. I'm not worried about the inside right now. I'm not worried about what's on the inside because I'll do that later. I'm not worried about what's on the inside. I'm just worried about what's on the outside. And the outside says something squared. So if you had something squared, how would you find the derivative? Move the 2 to the front and take away a power, right? That's what we're going to do. I'm not concerned about that something on the inside. I'll do that later. Now let me focus on the inside. What's the derivative of sine? Cosine of x. Cosine of x. So since it's to the first power, I don't need the parentheses. Done. Okay. All right, let's do letter D now. Letter D, which is on the next page. Okay. Letter D, we said rewrite it. We rewrote. Now, like I said, you can do the quotient rule for this guy. It works. The quotient rule will work. But since we did the quotient rule, we've already done that. I'm going to give you another way. I'm just giving you another tool to use. Will you use the chain rule on every problem? No. Will you use the quotient rule on every problem? No. Are you going to use the product rule on every problem? No. Are you going to use the power rule? Probably. Power rule's very, very popular. Okay? So just because we're doing chain rule today doesn't necessarily mean you're going to use it on every problem. This problem, you don't need it. But you can use it. I'm going to show you how. Okay. All right. So the outside is this stuff here. Something to the -1 power. So how would I find derivative if I had something to the -1 power? I would move to the power to the front, so -1 in the front, and then subtract a power, so I get -2, right? Rewrite the something. Now we do the inside. What's the derivative of the inside? 5. Calculus is done. That's the derivative. For all intents and purposes, that's the derivative. But I'm going to clean it up a little bit. I have the -1 in front times 5. I can multiply those to make -5. And then the 5x plus 1 is -2 power, so I'm going to move it to the bottom and make it squared. That's the answer you would see on a multiple choice. If you were doing multiple choice, that's the answer you would see. Okay, that's the chain rule right there. That's the chain rule. The only difference between what you did today and what we've been doing is that it just has layers to it. It has layers to it. Okay, so let's see. Yeah, let's not do those yet. Okay, so let's do a couple practice problems before we get into some heavier stuff. Find some room or a separate piece of paper. I'm going to give you some practice problems before we move on to the heavier stuff. So we'll call this E. Okay. Let's see. The third root of 6x squared plus 1. Find the derivative. That's the third root of 6x squared plus 1. So the outside was the entire thing. Something to the 1/3 power. I'm not really concerned what's inside the parentheses right now. I just know it's something to the 1/3 power. So we move the 1/3 to the front, take away a full power, so that's 2/3, negative 2/3. Rewrite what's on the inside, and then find the derivative of the inside, which is just 12x. So I can multiply 1/3 and negative 12. I can multiply those two guys together. So it's 4x. And then this guy I can move to the bottom. Give it back its root, and now it's got a squared. It's got a squared because the top is a 2 now, not a 1. Done. Okay. Let me give you one more, and then we'll go back. So the only difference between these problems and the ones we're going to do here later is that there's more layers. So the next problems, there's multiple layers. These are just 2 layers. So let me see. We'll call this letter F. One over 4 minus 5x minus x squared. Find the derivative. Oops. So I changed it first. I changed it to a power instead of a fraction. You could use at the beginning, when you first see this problem, you could use the quotient rule. That'd work. Nothing wrong with that. Or you can use the chain rule. Chain rule needs a power though. So the outside is something to the negative 1 power. So we move the negative 1 to the front, subtract a power, rewrite the something. Times the derivative of the inside. Derivative of the inside is a binomial this time. It's a binomial this time. It's negative 5 minus 2x. That's the derivative. So when I simplify it, I have to distribute this guy to this guy and that guy there. So it's going to be positive 5 plus 2x Move the other guy back to the bottom. Done. If we were to use the quotient rule, isn't the quotient rule the bottom squared? And isn't that what I have here, the bottom squared? So that's how you see it's the same thing. It would be, you would get the same answer. Okay. All right, let's try some with more than one level. So the difference between these and the ones we just did is there's multiple levels. So we've only had 2 levels, outside and inside. Now there's going to be an outside, an inside, and an inside, like an inner. That's the difference. So there's going to be 3 levels. I think one of them might have 4 levels. Okay, that's the only difference. So the first thing we're going to do is just do that. Let's find the outside first. So first thing I'm going to do is I'm going to rewrite this. It's got the third power there. You see the sign of 3 power? Let's rewrite it. So sine, and I'm going to rewrite this to 4x plus 1 to the 1/2 power, right? And then all of this is to the third power. When you write it like that, it's a little bit easier to see what's the outside, what's the inside, what's the inside. Okay, let's start with the outside. The outside's probably the easiest one because it's everything. The outside for this guy is everything inside to the third power. So something to the third power. Okay, the next inside is inside the brackets. The stuff in orange. That's the next inside. And then the last layer, actually, no, this one's got 4 layers. The next layer is going to be this guy to the 1/2 power. And then the last inside is inside the parentheses. Yeah, I'll do that in blue. 4x plus 1. So this one has 4 layers. So with the quotient, with the chain rule, you just find the derivative of the outside. Okay. Then find the derivative of the next inside, the next inside, the next inside. Okay. All right, let's look at B now. I'm going to rewrite B. Okay. I don't want a fraction because I'm not using quotient rule right now. So I don't want a fraction. So I'm going to say 3 parentheses the bottom to the -1 power. So I'm going to move the bottom up. Now, inside the bottom, there's a couple things, right? I give myself more room. Use brackets instead of parentheses. Okay. So I have tangent 4x squared plus 1 to the 1/2 power. I think that's it. Okay. So the outside is 3, the whole thing. So when you're focusing on the outside, it's just that part there. 3 in front, something to the -1 power. So to find the derivative of that, I would just move the -1 to the front, take away a power. The next inside. The next inside is inside a level. Tangent 4x plus 1 to the 1/2. Okay, then I got another level. This, wait. Yep, to the 1/2, sorry. Four x squared plus 1 to the 1/2. And then the last level is just 4x squared plus 1. And that's it. It's all about levels. Once you find the levels, then you're just doing derivatives, and it's not bad because it's kind of like 4 mini problems. That's really what it is. You find the derivative of, so we move this guy here, subtract a power. That's the first thing. And then this guy here, you're going to find the tangent. What's the derivative of tangent? Secant squared. So it would be secant squared, all of this stuff rewritten. And then this guy here, well, you have something to the 1/2 power. So you would move the 1/2 to the front, subtract a power, and go there. What's the derivative here? That's just 8x. And then you just chain them all together with multiplications. Okay, let's see. I don't want to do number 4 yet. Let me give you one more practice problem. We'll be done. We got 8 minutes. So let's go back to those. Before we get to that heavy practice stuff, let me give you one more practice problem. Letter G. Then we'll be done for today.
No, they don't. I just want to know more details because
Okay.
they're going to find it zero.
Well, this one I'll do with you guys because it's got another layer to it. Okay. So it's got a fraction, it's got a root. So I got to move the root up, and then I got to change the fraction to 1/2 power. That's what I did so far. Oh, sorry, negative, yeah. Negative 1/2, sorry. Wait, no, I don't need a negative because it's yeah. The reason I don't need a negative is because it's already, so the negative 1 takes that place. So I just need a positive 1/2.
So if you had the fraction as a negative, you would make the negative one. Like, did you switch it?
Oh, so the negative 1/2 instead of positive. No, you couldn't switch it because, wait, could you switch it? Oh, yeah, no, you could, yeah. Because I can multiply, yeah. That's actually a better way of writing it. Instead of that, like that, I think that'd be better, yeah. Less levels. This one's only got 2 levels now. So the outside level, something to the negative 1/2 power. Okay. So we move the negative 1/2 to the front. 3x plus 5. Subtract 1 whole, I would get negative 3/2. Chain. Now the inside. 3. Multiply negative 1/2 times 3, you get negative 3/2. Move this guy back to the bottom. It's going to be the square root of 3x plus 5 cubed. Okay. So those have 2 levels. The only difference with the ones we're going to do tomorrow is it's got 3 levels. That's it. It's the same thing, though. You're going to do the same thing. It'll look a lot more, but it's really not. Okay.